Ladies and gentlemen, our next session is Sense City, giving a sense to everyday city data. Please welcome with me Mr. Carlo Ratti, professor at MIT University and director of MIT City Lab.
Thank you. Thank you. Good afternoon, everybody. So I never felt like this almost on a circus, but I know I'll try to move around and show the slides. So what I decided to do today, we've got around an hour. First of all, I want to keep some time at the end for question and answers so we can have a bit of a discussion together. And I divided my presentation in two parts. In the first part, actually, we will look at the data, what type of data we can get from cities and what we can do with it. And then following that, actually, we look more at architecture, planning. I mean, how some of this can be used in the city, in the process of city making, which is so important here in Dubai. Now, let me start, and I want to start with this picture. The reason I took this picture is that something quite interesting happened in Formula One over the past 10, 15 years. 10, 15 years ago, if you wanted to win a Formula One race, you need a good car and a good driver. Now, today, if you want to win a race, you still need that, but you also need something like this. A system that's made of thousands and thousands of sensors onto the car, collecting information in real time, sending it to those computers where it's analyzed, it's processed, and decisions are made in real time. In other terms, if you're an engineer, you would say that this is a real-time control system, which is a system made of two components, a sensing component and an actuating component. Sensing is about collecting information from the system. Actuating is responding to that information. And sensing and actuating is really the principle for every living system and for every dynamic system. When we meet each other, we sense each other, we shake hands, we collect information from each other, and then we respond to that information. Now, the amazing thing we believe is that today our cities are starting to behave a little bit like that Formula One racing car, a real-time control system. Our cities are being covered layers with many different types of digital information, of networks, and so on. And because of that, the way we can collect information from them, the way we can respond to it is changing. And let me give you just one example. If you look at this, you see the growth of mobile connections on the planet over the past few decades. And it might be surprising today to think that just back in 1980s, we could live without mobile connections. The first one, actually, first citywide cellular network is 1979 by NTT in Japan. And then it took over 20 years to get to 1 billion. And look how fast this has been growing since then, 2 billion, 3 billion, 4 billion, and so on. Now we are almost at the same amount of mobile connections as the population of the planet, 7 billion. Now, you might say, how much more can this grow? There are 7 billion people on the planet. Well, according to Ericsson, who never missed a prediction in this space, we are just there, as you see at the bottom, and we'll be at 50 billion in 2020. Now, how could it be? Is it that each of us is going to have 17 iPhones in our pockets? Well, not really. The point is that we started by connecting people with people, and then we moved by connecting people with data, people to machine to data. So machine going online, and more M2M, machines talking to other machines. Almost as every atom out there, the physical world, is becoming, in the long term, both a sensor and an actuator. And that is producing incredibly new potential for understanding cities, for controlling cities, for collecting data, and for analyzing this data. Now, everybody these days talks about big data. Well, I will show you some example of big urban data. And one way to describe it is just to look at the sheer quantity of it. If you take all the data produced by the beginning of civilization till 2003, well, that's more or less the same amount of data we now produce every 24 to 48 hours. So that gives you an idea of the quantity, the sheer quantity. It's not the same quality. If you take the first chunk of data, well, there you had everything. You had Shakespeare, Muhammad, you had Dante, you had everything that civilization produced until 2003. I mean, all the text and information until 2003. So the quality was different, but the quantity is the same than what we produce now every day or couple of days. Now, there's another definition that's by a friend who's a professor at UCL in London, is Mike Batty, and he says big data is what you cannot put in an Excel spreadsheet. Now, it seems funny, but actually it's quite profound. The point is that big data needs new tools in order to be analyzed. So you cannot use it with the traditional tools we are using today. And what I want to do with you is actually share with you three different types of data. Data that's opportunistic, user-generated, and purpose is sense. Opportunistic first is the data that is collected by somebody think about a cell phone operator, and actually a very pleased and thrilled to actually have just started a collaboration with Do here in Dubai and starting to work with some of the data to describe the city of Dubai. But this is data that is collected for something else, for running a telecommunication network, and you can take it and use it to better understand what is going on in a city. And the first project I'll show you is one of the first projects we did at our lab. It's a project now dates back to 2006. And 9 years ago, it was at the pavilion in the Venice Biennale, and that was the first time ever that we took data from a big city with millions of people moving with cell phone and trying to use it to understand what is going on in the city. Now, the city in question was the city of Rome, the Italian capital, and what you'll see here is actually what happened on a very special day in Rome. That was the day of the final of the Soccer World Cup. It was Italy playing against France. They were playing in Germany. And look at what happened in real time in Rome by using data from the cell phone network. So what you see here is the city. You see before the match, you see the Colosseum, you see the river, people moving here and there. It's the early afternoon. And then the match begins, silence, nobody talks anymore. France scores, Italy scores. Half-time, people make a quick call. And then second half, end of normal time, the first overtime. Some of you might have called the headbutt by Zidane, which is now, and finally, Italy wins. So then, people move, everybody moves to the city center. You see the big peak over there. Then it's the evening, it's the middle of the night. The following day, actually, the winning team went back to Rome, to the city center, and, the prime minister and all the Romans went to celebrate. And by the end of the day, people went to have a big party outdoors. So you see a little peak at the bottom of the slide. It's called Circo Massimo, how it goes up, really, when everybody goes there to celebrate at the end of the day. Now, this was just, the pure data. But if you analyze the data, you could do actually quite interesting things with it. So what you see here is actually the UK. And what we did was build the biggest ever social network. It's a social network built using telecommunication data and connecting every point with every other point. And then we ask ourselves, what if we can use this information in order to better understand the structure of the UK? How the UK communicates with Scotland, how the regions of the UK are really structured, not because of politics, not because of other reasons, but just because of how people communicate with each other. Here is a little video. So how we can redraw the map of Great Britain with a network of human interactions. Every time we got a phone call, we'll build a link between two places. And then if we add the links across the whole country, we get something we could call like the human network. And then the question is, how could we use it in order to better understand regions? So you analyze it mathematically, which is what you see here. Here you visualize it, but it's a mathematical analysis. And what you see is quite interesting because some regions look very much like the regions we know, such as Scotland. But other regions are different. They're really based on how people communicate. Wales, for instance, is divided into three parts, that are very connected with the center of England, with the UK, with the rest of the UK. So really it's a geography that's not based, as I was saying, on the past, on history, on politics. It's a geography that's really based on how we all communicate with each other. And that's the same thing across the United States. That was from the New York Times, actually, how, again, you can better understand communities in the United States. And this was also used then later by the New York Times in order to look at voting patterns. By how people communicate with each other, it can tell you something about how communities behave in different ways in terms, for instance, of their voting behavior. Now, there's other type of data you can get in an opportunistic way. What you see here, for instance, is all credit card usage in Spain. And what you see is just before Christmas, look at how people go and shop, how much they go and shop before Christmas. You see grocery, hypermarket, bars and restaurants. It's, big holidays across all of Europe, and people really going on the 23rd of December to buy a lot of presents. On the 24th is when everybody remembers all the things they haven't, all the gifts they haven't bought. So you see a big peak, a big explosion. And that's all credit card data. Again, you can use it almost in real time. It tells you what is happening in the country. And then you go to the 25th, which is actually the celebration day where nothing happens. You see it's very, very flat. just a small spike with bars and restaurants. You see Madrid, Barcelona, the main cities in Spain. Now, you got this data, and then again, you can analyze it. You can analyze it and see, for instance, again, big data, huge amount of data. You can see how different businesses attract clients. That's small businesses, where their clients are coming from. And you see how this changes with distance. If you actually want to go and buy food, you usually don't go very far. If you look at the distance in kilometer on the x-axis, on the horizontal axis, then people go just not that far. But if you look at fashion, for instance, you see that people are ready to travel much further away. You don't go every day, unlike food, you go very often. You go maybe once a month, and you're ready to travel much further away in order to buy fashion. And then you can look at this across different categories, as you see how they change between one and the other, and how they're all connected with each other. So what you see here is actually the network that tells you how all businesses are connected because somebody is shopping in one place and another place. The link between two nodes means two businesses which share clients. And when you look at it again, you can understand how the structure of commerce works in the city, and more importantly, how you could actually make it better as a planner. So it becomes very valuable data to understand the city and potentially to design the city. Now, these were just two examples of opportunistic data from cell phone or from credit cards. There's plenty of other domains. I want to show you one more. This is data from GPS. What you see here is actually the city of Lisbon. It's a visualization that shows you all of the taxis moving in the city tracing their GPS points. And again, that's just a visualization, but when you analyze it, you can do quite amazing things. So what you see here is all the pickups and drop-offs of taxis. Same data as before, and you see it here in the city of New York. Sorry, it was moving a bit the image. I don't know why. So basically, pickups and drop-offs in the city of New York. What you see here is actually JFK Airport. And then you can zoom out, and here you see all of New York, Manhattan, and then the boroughs. And then you can ask yourself, what if people could share a taxi? What if then, these days, the sharing economy is picking up in many different domains. People seem to be happy to share even very intimate spaces, such as apartments or bedrooms on Airbnb or couch surfing. So what if people could share more? Mobility and transportation. Today it could be a taxi, tomorrow it could be like, a little van that you could be actually used between different people in a communal way. Then, that's the idea. So imagine that's a hypothesis, so that people will be ready to share more. And then the question is, how could you quantify this? Now, again, there's a lot of big data you get from the city, and you need to analyze it. And the way you analyze it, if you use traditional mathematical ways, doesn't really work. So what we did, this is a paper we did recently in PNAS, the Proceeding of National Academies of Science. And so basically, it's about, how can we quantify in a new way the benefits of vehicle pooling? And what you do, you use actually, in this case, we use network science in order to solve the problem. What you see here is the methodology we use. You turn a dynamic problem into a static one. And what you find is quite extraordinary. What you find is actually in New York, you can take everybody to destination when they need to be there, but you could cut the fleet of vehicles by 40%. So that means, you have the infrastructure you have today. If you use it more efficiently, you can actually reduce it immensely. And incidentally, some of these results are the results that inspired a number of things that are coming out around the world, including we're starting to work with Uber, who told us that by looking at the results of the paper, that was part of the reasons they launched Uber Pool as a new service on Uber. So that becomes something interesting that you measure, you quantify, and then can have an impact because people can launch new services. Now, all of this is about existing systems. So you take a taxi system, you look at the data and you analyze it. But think about tomorrow with self-driving cars. And we saw at the museum just next door a lot of information about self-driving cars. This is what actually a self-driving car sees. Self-driving car looks a little bit like the human eye. It uses a LiDAR, like what you see here, which actually scans the environment all around itself in order to make a three-dimensional model. Well, when you go self-driving cars, then everything changes again, because you can not only share the ride, but you can share the vehicle much better. The car can give you a lift to work in the morning, and then can give a lift to somebody else in your family, or to anybody else in the city. So what you are doing actually is creating a system which is in between public and private transportation. And when you do that, if you combine this with what we saw before about the sharing of the rides in your city, you potentially can have a city such as Dubai or New York or Singapore or London, where with 20% of the vehicles you satisfy the mobility demand of the entire destination. That is, of course, theoretical. You don't need to, it's not that we say this is how it should be, but actually it shows you how much potential there is to create new different ways of transportation between public and private that actually will move people around. Now, if you look a bit further down the line as well, you can think about other changes in the city. For instance, we are all familiar with this. That's a traffic light. And traffic light didn't exist once upon a time. They came into existence, more or less when motorized transportation, a little over 100 years ago, came into existence. And since then, they've been the primary mode of negotiating access to road intersections. But what about doing something like this? What about thinking a new system when everything is self-driving, where cars will actually mix without bumping into each other in a similar way? Don't try it yet, but but this is what you could do. And again, what is important is to quantify what the impact of this could be. So that's what we are doing. Again, you need to develop mathematics in order to try to address this question: how much more efficient, how much safer you can make it. And it turns out that actually such a system could have a big impact on our cities as well. What you see here is actually a crossing in Singapore. What you see is the same number of cars getting there to the left and to the right. If you look at it, it's the same number of vehicles. But to the left, you got the most intelligent traffic light system that exists today. And to the right, you actually have a slot-based system. And even if safety is the same, at the bottom, you can see the delay per cars and the number of cars waiting in both cases. And look at the difference, how many people are queuing to the left and actually how much more efficient it is to the right. So this was just to give you a quick glimpse into opportunistic data, how we can get data from the city, from GPSs, from cell phone companies, from credit card and so on, and there's many other different types of data, and how we can use it in order to better understand our cities, but also to transform them. We use this data to make models, and actually the models can help us to design different cities. Now, let's look at the second type of data, which is what is usually called as user-generated. It's all the data we produce. We produce every day when we log online, when we post on Facebook, on Twitter. In this project, for instance, our group a few years ago was one of the first ones to look at Flickr data, and actually to look at where Flickr data is coming from. As you know, Flickr is a database to share and to upload a lot of images. And we started by looking at a place such as Tuscany, and looking at where tourists go. So here you see people who take pictures in Tuscany. You see to the left, you see northern part of Italy with Tuscany, and you see Florence over there, a bright spot. And then you can zoom into Florence and you see downtown. You can even identify the key points, Ponte Vecchio or the Duomo. And then you zoom it all the way to Santa Maria del Fiore, to the Duomo, and you see there, all the places where people actually take pictures. Now, if you want to be slightly more sophisticated, what you can do is actually look at every picture taken and look at when it was taken, the time, and look at who took it. All this information is open, is publicly available. So if you just go and read it in the header of the picture. And then you can do actually trajectories. Like you see here, you can see how people have been moving over space. So now I've got a question for you. So here you see Italians and Americans moving in Tuscany. Now, where are the Americans? To the left or to the right? Raise your hand. If you think Americans are to the left, raise your hand now. Americans to the left. You need to make up your mind, one or the other. So Americans to the left, okay? Americans to the right. Okay, more or less 50-50. So, well, Americans here, the first group actually won a prize. Americans are to the left. You see, if you come from the United States, you go to Italy, you might go once in a lifetime or once every 10 years. So you go to the main cities, to Genoa, to Pisa, to Florence, to the biggest city. But actually, if you're Italian and you've been there many, many times, then you will go there and look at the little villages. Look at how people explore, you know, the most remote places, like little island called Isola d'Elba. Did you see Island of Elba? Did you see there, you know, there's virtually no Americans, at least on Flickr there, but actually plenty of Italians who go there. So how this can really help you to better understand the place? Many other things. This is something that actually our students in our lab were quite passionate about, was using this data to understand where is the best place to go clubbing in Barcelona. So you look at the pictures and you look at where they're coming from. And again, you know, you can understand the places where people are having parties. They even managed to get some scientific results about correlating the geography of Brits and parties in the city. And if you want, you can also look at analyze the data, use more analysis on the actual, do image processing on the data. And then, like you see here, you can see different things. In this case, for instance, we look at the green, and we use it as a way to monitor drought. As it gets very, very dry in Spain over the summer, then the country changes color. And the way you can monitor that, of course, is in a traditional way. You put a lot of sensors in Spain, but there's a way to monitor it which doesn't have any cost, which is looking at all this. And by looking at how the color changes in the course of the year, you get a sense, a core sense, but at the same time an approximate sense of what is happening in terms of drought. And you know, we call the project the world's eyes, los ojos del mundo in Spanish, is a way to really use or appropriate the eyes from all of us in order to understand what is going on in the environment that surrounds us. There's many other type of data. Just one more example about data that's user generated. This is tweets. Actually, we looked at different type of things in tweets. In this case, we look at tweets during the golf tournament, and we discover something quite special, that when people are very excited about something, the length of the tweet gets shorter and shorter. And you see it here in the video. So you got long tweets at the top, short tweets at the bottom. The yellow line is the average. And this is the golf tournament. The intensity tells you how many tweets you have on the system, so how excited people are about something. These are the tweets, you know, before there's long comments, and then very short comments during the round with bursts of excitement. And the same happen every day, all the way until the final. So here you see the whole thing, you know, basically based on the tournament, what happens on the system and how the system responds. So again, becomes almost like a way to get information about all of us. You know, the response that we post online becomes a way to explore what we're calling in this project the signature of humanity, the signature we leave outside when we go online. Now, a final thing I wanted to share with you here in terms of data, the data that's been purposely sensed. So something where you can actually take a sensor and you can distribute it, and you can use it in order to collect some information. The first project is a project we did recently in China. As you know, in China, air quality is a great concern. And so we decided to focus on China next to Hong Kong. Hong Kong and Shenzhen, they're two cities. They're almost like the same city. As you know, they're very close. But there's a big difference. They're separated by the border, the mainland China border. So what we did, we decided to go and measure air quality, but in a new way. Not air quality in a traditional way, where people put a big sensor into the city, but actually giving very small sensors to people, so the people themselves can actually collect information about air quality and then make different decisions. Here's a video that tells the story. So those are the small sensors. And the color tells you the level of pollution. Green is cleaner air. Now we're crossing the border to Shenzhen. So there's one example of how we can actually deploy sensors. In this case, people themselves can become almost sensor and collect information about the environment. In this other project, we looked at that computer, the computer you see there. And actually, today you know everything about that computer. Every chip in that computer, you know where it was produced, how it moved on the planet, how it became that machine. Today we know everything about the global supply chain. But we know very little about what happens to things when we throw them away. Sometimes this is what happens. When you throw away electronics from Europe, sometimes they ship illegally to Africa, from the United States, sometimes to Asia. So our idea was, what if you could put a little chip on trash and start following trash? We couldn't find anything off the shelf, so we worked with Qualcomm in order to develop this little chip that you could put on trash. And we did a first deployment in the city of Seattle. We had 500 people came with their trash, 3,000 different pieces of trash. We put a tag on all of them. And so what the tag does, it reports its location, so it traces what happens to our waste. So it helps us to understand much better the waste management system in the city. What goes to the right place, what goes to the wrong place, and so on. So this is actually what we started collecting. 3,000 objects. The day of deployment in the city of Seattle. After a few days, you see some of the main landfills next to Seattle. But actually a big surprise, how far things started to travel. Sometimes in crazy, unexpected way. Look at the trace that went to Chicago and then down to Baja California. And then it's still moving after 1 month or 2 months. So this was actually information about, that we can collect for things that are much more difficult to capture in normal ways. And actually nobody, even people, a lot of companies who are working with us involved in the waste management chain, had very little idea. Everybody today does a small piece of the chain. This was the first time we'd actually trace all of it by using sensors. Now, this was just to give you a quick overview of the different type of sensing data we can sense today. I said opportunistic, like we were saying, like from cell phone, from taxis, from many other things that we are collecting anyway, we can use. User-generated, so all what we leave, all the traces we leave online, on Facebook, on Twitter, on Flickr, everywhere. And then also, because we deploy sensors, so like we saw for trash. Now, there's probably a fourth category I didn't mention here. In this fourth category, you could call it serendipitous, or data that you were not expecting at all, but you can get. I'll tell you one little story. We did this project about tracking trash. It's still going on. Actually, we're looking at international waste and e-waste flows, illegal e-waste. So we're looking at a number of things. And so we had a lot of stuff in our lab, tags and computers that actually tell you where to go. And then what happened is that the burglar came to our lab at MIT. And the poor guy stole a lot of things, including the tags and the computers that tell you where they go. And this is what happened. right, so this was actually the first my presentation. I want to share with you how we can collect such incredible amounts of data in our cities and in different ways, and how we can then analyze it and do data analytics. But then the second part, just with a few examples, I want to share with you, so what about our cities? How can we use at the beginning? We talked about actuating the city, about transforming the city. So in this case, I want to look about, what about architecture? How we can transform all of this then into the space we live in. And I thought this would be very relevant in a place such as Dubai that's developing at such an incredible speed. So how can we actually transform some of this in planning and architecture? And we look at this from the small scale to the larger scale, and with some projects actually done both by our design lab, but also by our lab at MIT, but also by our design office, which is doing the projects that are more related to architecture. I wanted to start with energy. I mean, this is probably not a big energy in terms of heating. Heating is probably not a big concern in this part of the world, but it is certainly a big concern in Boston, in Europe. What you see here is actually how much energy we put in buildings that are empty. We've been monitoring a bunch of buildings and looking at where the energy goes and where the people are. And what you realize is that you throw a lot of energy to heat up places where there's nobody. So in this project, for instance, we said, what if you could actually concentrate energy more on people? So instead of heating the whole space, we could actually just heat like a bubble of heat around where people are. We did the first test. This was last year. So this is the main entrance at MIT. So we started creating a bubble of heat around people as they moved into the space to see how it would work. And then you can also customize. You can say you want to be at 17 degrees, you want to be at 25, you want to be at 22. So everybody can have their own bubble. This year, just until a couple of months ago, we had a big installation at the Venice Biennale. It's an exhibition about architecture that happens every 2 years in Venice. It was really that was actually creating these bubbles of heat and follow people as they moved underneath. So that was about creating this bubble of heat. Actually, some of you might have seen at the museum just next door. This is actually what we did as a personal cloud. Similar idea, but actually how you can spray, use evaporative cooling, something that's so beautiful in this part of the world where you actually use water in order to cool air. But instead of doing it for everybody, you can actually do it under a canopy and just do it in a selective way. So you create a little cloud of cool that just follows people around. And again, you can save a lot of energy, but also it's quite fun. Some of you might have seen it, tried it out there, so it follows you as you're moving. And there's also a bit of lighting effect connected to it. But when you're underneath, you see the temperature immediately goes down by 5 or 6 degrees just around yourself. So imagine, how Dubai or many other cities in this part of the world could use much more outdoor spaces. Could have much more outdoor life even during the day, during the summer when it's very, very hot. If you just were to provide localized cooling for people who are underneath it. Other examples of how you can use this, how you can bring information in a pervasive way in a space. In this case, we actually looked at just an interior design project. Here you see it without any information, but then the interesting thing of this place is that every wall over there could become a projection surface, could become animated by projections all around. So one single space, the whole place can become animated by projections. Or in this case, we'll use water. This was actually the World Expo a few years ago, 5 years ago. The theme of the expo was actually water. And the mayor of the city came to us and said, what can we do with water today in a different way? Water has been such a beautiful ingredient of architectural planning for thousands of years. What could we do today in a different way thanks to digital technologies? And what we decided was, imagine you have a pipe, what you see there, and on that pipe you've got many valves, opening and closing, controlled by a computer. Then what you can do, you can create like a living water wall, something where you can show images or text or pictures, or that opens up when you approach it. So the mayor liked the idea, so we got the commission to design the building at the entrance of the World Expo. We call it Digital Water Pavilion. Every wall is made of water. There's no doors or windows, but it opens up when you approach it. When you go inside, all of the walls expand and shrink based on people. The roof is also covered with a thin layer of water. And then if you got too much wind, you can actually lower the roof to minimize splashing. Or at the end of the day, you can close the building and the whole architecture disappears. Hopefully without anybody underneath. We have got sensors for that as well. So we did the video. We had a lot of fun doing the video. We didn't know if they would actually build it. Then what happened is like 9 months before the opening, before the World Expo, Time magazine in the United States named it Best Invention of the Year. So, in the last minute, we had to actually really work together in order to make it happen. Here was the building before the opening. What you see is actually, I like this picture because that person you see has a trolley, was going to the station, but stopped there to ask, what the hell is going on here? So, what is happening? When this was the first test, so nobody has seen it yet. It looks like sometimes the water is almost, based on how you cut it, it looks almost like it's going in reverse from the base to the ceiling. So it has this kind of very magical effect. Here is the water plus projection, so how the two interplay and how to overlap and superimpose each other. Here it was myself trying not to get wet, testing the system that actually cuts the water when you want to get in. And I should tell you now what happened one night when all of the sensors that control the building stopped working. We're using all this data, we're collecting all of this data from our buildings, from our cities, but sometimes computers crashes. And the night we were terrified because we didn't know what would happen. That night, the building would keep on doing its own crazy things and cuts and holes and writing and text, but without responding to people anymore. But actually, that night was one of the most fun nights ever. That night, thousands of kids from all over the city went to the building to play a new game. Not anymore a building that responds to you when you approach it, but a building that you need to engage like this. And for us, it was an important lesson because, as architects, engineers, we always think that we know how people will use the stuff we design. But then reality, and especially human reality, is always a surprise. In this case, it was a good surprise. These two pictures are the one I wanted to show before. Probably they went into the wrong place of the building that responds to you where every surface can become a surface. And the final thing I wanted to share with you is a project we are doing now with our design office. It's for the Olympics in Rio. Here in this case, we actually tried to think, how we were given a brief by Arfuturis, one of the main architecture foundations in Brazil. And the brief was, how can we create a pavilion in the city of Rio that could become a bit the symbol for the Olympics next year. And one of the important things in Brazil today is actually water. Brazil is undergoing an incredible water crisis. The city of Sao Paulo is actually now thinking about rationing water. And so the point was, they told us, can we do something to tell people about water, about how you purify it, how you use it, how you should save it. And so we decided to say, well, what a better place to talk about water than actually going on water itself. And what we decided was to develop a new system, which is based a little bit on the technology of submarines. Submarines can move up and down. If you do that, but you do it faster, you can have something that cuts the water exactly at the level of the surface. So our idea was, can we create an architecture which is not based on addition, but is based on subtraction? So we just cut, from the surface of the water, we cut down all these different spaces. The spaces that you see there, they have different functions, a function for education where you can learn about water, you can go to a cafe, you can listen to a conference, you can grow hydroponic plants over there. You can also have a swim if you want in purified water. This is for Lagoa. Lagoa is a beautiful part, a beautiful lagoon in Rio, where some of the Olympics will happen, but actually where the water quality is not yet that great. They've been trying to ameliorate it over the past few years, but it's not yet that great. And here you can see how they imagine that this could actually become a part of what will be the experience of water, but more generally the experience of Rio and the experience of the Olympics. I want to share it with you. It's actually in progress. It's work we've been just commissioned to do. It's anyway. So I just want to share it with you. It's one of the first time I'm showing the project. And I wanted to stop with this to say that all these demands of data that we collect from our city can help us make more responsive buildings, more responsive architecture. In architecture, the senses and response, that responds to us when we approach it, but the response to the city and to citizens at large based on what they do and in how they live and enjoy the city. I'll finish here. And I think it would be great actually to have, I left some time at the end to have really question and answer and discussion and comments and really engage in a conversation with all of you. Thank you.